into electrification big time at Ford, spending over $11.5 billion on electrification. And we're doing that with all of our iconic products, whether it's the F-150, whether it's the Mustang, whether it's the Transit. Those are all the vehicles that people know us for around the world, and we're leaning into that big time because that's where we excel. Whether it's play with the Mustang, work with the F-150, we're going to take electrification and we're going to show how it can enhance those experiences and get you a better product at the end of the day. So now is the right time. This is where, I mean, we're at a pivotal point in automotive industry. We've got a lot in front of us as far as sustainability, and this is the time now to start really leveraging the technology and learning it so that we can apply it to the entire portfolio. So there's no better time than now.
At General Motors, our vision for the future is a world with zero crashes, zero emissions, and zero congestion. The key to unlock that vision is electrification.
Hello and welcome to Electric Vehicles and Machines. I'm your host for this digital presentation, Scott Garvey. Well, as you might surmise from watching those first two clips, electric vehicles are definitely on the horizon. Well, in the not too distant future, garages are going to be home to more than just electric remote control vehicles like my little Blazer here. The average family car is going to be electric. That includes the average family pickup truck on the farm, too. In fact, General Motors has pledged to make its entire vehicle fleet electric by the year 2035, and other manufacturers are following that trend. But when I bought my little Blazer, one of the questions I had for the sales clerk was, how long will a charged battery last? How long can I run the thing for before I need to go home and put it back on the charger? That has been a question potential consumers have been asking the major auto manufacturers too, and it's been holding back sales of electric vehicles a bit. Well, more than a bit, so much that manufacturers are calling it range anxiety on the part of potential buyers. But there's been a lot of R&D done on battery technology in the last decade or so, and range is growing significantly. In fact, GM's new battery technology they call Ultium is changing the landscape for range. One of the technologies, that is. In fact, they believe that in the foreseeable future, buyers of GM vehicles with that technology will be able to realize a range of 600 miles. Here's a look at what their Ultium battery technology is all about and where it's at now, and how it fits into the architecture of a vehicle.
Ultium is the world's first hyperscale electrical vehicle platform with the power to make almost any vehicle an electrical vehicle. A combination of groundbreaking battery architecture, highly flexible electrical propulsion systems, and a common high-energy battery cell that will power an entire range of next-generation electrical vehicles. It all starts with the battery chemistry. Lithium-ion batteries typically use a blend of nickel, manganese, and cobalt to produce reliable power. Ultium's battery chemistry reduces reliance on cobalt by 70% through adding alumina. This reduction in cost also addresses the challenges of sourcing sufficient cobalt to match the growth in demand as the number of EVs on the road increases. The foundation of our platform approach is a single common cell design that can be used across all our vehicles. This will be the best large format cells in the industry, optimized to provide sufficient power for multiple vehicle designs. And we manufacture those cells in-house as part of a joint venture with LG Chem. The cells will produce 60% more energy capacity than our existing electrical battery cells, and use a flat rectangular pouch design that reduces the space between cells and can be stacked more efficiently into modules for higher energy density in a smaller space. Vertical stacking of cells within modules helps us build trucks, SUVs, and large crossovers. Horizontal stacking enables low-slung performance vehicles. And in between, we have the platform for mid-size and compact crossovers. The modules themselves are state-of-the-art, using 90% less wiring than our current batteries to communicate between the cells, increasing the amount of power available per square inch. General Motors will be the first automaker to use an almost completely wireless battery management system for its production electric vehicles. The system monitors and balances the cell chemistry on a constant basis, ensuring optimum performance and charging capacity. Finally, the modules are placed into the vehicle's battery pack, a structured enclosure which doubles as part of the vehicle's chassis and protects the cell from damage in the event of a crash. We can use 6, 8, 10, or double stack up to 24 modules in a single pack, depending on the power requirements of the vehicle. The end result of all these innovations is a battery that will produce up to 450 miles of range on a single charge, and nearly 40% less cost and 25% less weight than our current EV batteries. We'll combine all these innovations with an incredibly flexible propulsion system called Ultium Drive, which uses 5 interchangeable drive units to deliver front, rear, or all-wheel drive from a single system. The Ultium platform is a breakthrough in electric vehicle technology. And we are not finished. We are working on our next-gen high-energy battery chemistry that will reduce the reliance on cobalt and nickel even further, while reducing cost by 60% compared to the current batteries. We estimate these lithium metal batteries will deliver twice the energy density of even the Ultium battery cell, providing 500 to 600 mile range on a single charge.
Well, it turns out Ford and General Motors have demonstrated they've invested heavily in electric vehicle platforms. But what about the third name in the big three Detroit automakers, Fiat Chrysler? Well, it turns out that they had an announcement to make this spring. Every year that company brings a concept or prototype vehicle to Moab, Utah, to the off-road annual Jeep gathering. This year, the vehicle they brought was, you guessed it, an electric-powered Jeep Wrangler. Just like, well, these are Wranglers, but they're not electric. So what Chrysler did was they took a Wrangler, removed the gas engine and clutch, and replaced that with an electric motor, leaving the remainder of the drivetrain intact. Now, engineers say that allowed the electric Wrangler, dubbed the Magneto, to take advantage of the electric motor's high torque, even at low RPMs. So when it went along the trails at Moab, Utah, it could rock crawl and have no problems at all generating horsepower and torque.
Jeepster Magneto. This is probably one of the most interesting vehicles we've ever worked on for the Safari. This is a battery electric vehicle. So it doesn't have a gas engine anymore. That's been removed, and to be clear, it's a retrofit. We started with a two-door Jeep Rubicon. There are a multitude of batteries in this vehicle, and the whole reason for doing this was just to see what does a battery electric Jeep do in the off-road environment of Moab. Magneto is set to be kind of a test bed for us to answer those questions that we have curiosities about. We left the great Jeep articulating suspension in place. It has the Rubicon axles, the Dana 44s, front and rear. The transfer case, the 4-to-1 Rubicon transfer case, stays in place, and most notably, the 6-speed manual stays in place. And the reason we did that was to we get kind of the best of both worlds of the automatic transmission off-road and the manual transmission. So off-road, I can do lots of gear selection with the manual transmission, including the low range. I don't have to worry about the clutch, so I get the direct feel of a manual transmission off-road, but the ease of drivability of the automatic transmission. The fact that you don't have to slip the clutch to get over rocks or et cetera like that, because the engine can't stall. When the power, the torque is delivered, it's early, down low before the vehicle revs up. Interesting, usually when things go bad off-road, you rely on the power of an electric winch to get you out of a bad situation. The name Magneto itself is really derived from the power in electric vehicles, the magnets, and it's one magnet trying to get to the other. And it's a great torque delivery. We can drive this vehicle at very, very low speeds with high torque. And it's, again, a curiosity thing that we want to go to Moab with and share it, honestly, quite openly, and try it out in different terrain. So look for it in Moab, Utah, for us to be really testing and trying this vehicle out.
So range has been dealt with, or is being dealt with, by the major manufacturers, so potential buyers of electric vehicles can travel the distances they want. But the other consideration is, what about performance? Can an electric vehicle deliver the same kind of performance as a vehicle with an internal combustion engine? Well, the answer to that might surprise you, and it is that the electric vehicle can put the internal combustion engine vehicle to shame. So if you're concerned that potentially buying an electric pickup truck will not have the ability to tow a stock trailer full of calves to the auction mart in the fall, don't worry about that. And the reason I say that is this next clip from Ford will show you what their prototype electric F-150 is capable of pulling.
Good morning, guys.
Hey, how are you?
So as you can see, we're here at the rail yards. What do you think we're going to do today?
It's a mystery.
So we have a very special version of the F-150. And as you can see behind me, we've got 42 trucks representing 42 years of America's best-selling truck. Wow. Also, they line up to over 1,000 feet in terms of distance. So we're going to be taking this prototype and we're going to be towing 10 double-decker freight cars weighing over 1 million pounds for 1,000 feet. You guys think we can do this?
You seem confident, but I'll be shocked.
No other truck has ever done it, but we are going to do this.
Wow, you gotta see it.
I've got one major thing that I still haven't told you yet. You guys ready?
Oh, come on.
No. What? No way.
So this F-150 prototype is all electric.
On hero vehicle.
Ready?
Are you kidding me?
What?
Dude, it's moving the train. It's moving the train.
It's going.
It's moving. The
Yep,
vehicle is
it's-
moving. Yes.
You've got to be kidding me right now.
That is impressive.
That's
She's doing
unreal.
it so easy.
I can feel the weight of the train behind
Yeah,
us.
listen to the motor. What motor?
Everything, and we are at like 4.5 miles per hour finishing.
Great.
Just quietly pulling over 1 million pounds.
We're almost at the finish line. I can see it.
Amazing. Awesome. Okay, you can back off.
Told you we got this. So if you guys thought that was impressive, let's load the 42 trucks in and let's do it again.
No way.
That'll take us way over 1 million pounds.
All right, let's get her done. Come on, baby. Come on now, is it gonna work? It's doing it.
We're going.
It's doing it.
I can definitely feel the weight more with the 42 trucks in.
That is unbelievable.
Built more tough.
So now we're at 1.25 million pounds.
Yes.
Built Ford Tough is all about durability, capability, and productivity. And this all-electric F-150 extends Built Ford Tough to a whole new arena.
That's awesome, Linda. That's awesome. Yes.
We did it! This prototype will help us deliver the all-electric F-150 in the coming years. It was awesome. Felt like being a superhero. So we got some speed behind us. We could feel the torque being applied, and it was a lot of fun.
That's a look at how manufacturers are improving how much range and power they get from vehicle battery packs. But to get power out, you first need to get power in. So where can EVs get charged up? At least some manufacturers have said they expect new EV owners to get a charging station installed in their home garage even before taking delivery of an electric vehicle. That will handle the lion's share of the car's or vehicle's charging needs. But what if you want to take an extended road trip? Where do you recharge then? There are gas stations on nearly every other street corner now, but something close to that level of public charging station infrastructure will need to exist as the country's electric vehicle fleet grows. And that current lack of infrastructure is something that will likely hold back the widespread introduction of electric heavy-duty trucks, too. Yes, even the heavy-duty truck segment is moving toward electrification. Both battery electric and hydrogen-powered Class 8 trucks are already starting to appear. Some with brand names that aren't familiar to most people, but arguably the most well-known electric truck to appear so far is Tesla's aptly named Semi. Here's a look at its first introduction a couple of years ago.
I'm going to give the trucks a moment. Give the trucks a moment. All right. All right. Welcome to the Tesla semi truck event. I hope you like what you see. I'm going to tell you about everything that this truck can do. It blows my mind. I think it'll blow yours.
The Tesla Semi specifications may be mind-blowing, but it's still not ready for commercial release, while other brands like Freightliner have already jumped into the market with their electric version. That's an overview of what's happening in the on-road vehicle sector. But now let's take a look at things off-road, and more specifically, in farm equipment. One brand that has made several public announcements about its electric drives in the past is AGCO. I recently spoke with that company's Josh Ekholm, Director of Engineering for Global Harvesting Electronics, about whether or not ag equipment engineers are continuing to look at electrification in ag equipment.
Yeah, I mean, maybe to your first point about electrification, though, I mean that is an active area, and some of it's based on where, when we think of ag, sometimes we don't, me included, sometimes I don't think about all the areas that ag is, right? So when we think about some of the areas within orchards and some of those smaller farms that are close to or inside of those municipalities, in some areas of the world, that it's going to be a real challenge. We're going to need to have electric power in that range of tractor sizes in order to achieve what's needed to achieve to be able to run in those areas. I think that's a real risk, and maybe risk isn't the right word. It's a real challenge for all the companies to overcome. So there for sure is investigation into that side of it, and some real work done.
That work being done, at least at AGCO, dates back several years already. In 2013, AGCO's Fendt brand showed its X-Concept tractor to the public for the first time at Agritechnica in Germany. The X-Concept was a hybrid using a diesel engine that ran a generator to supply electric drives to implements instead of using hydraulics. In 2017, Fendt brought out its first battery electric concept tractor, the E100, to the same show, Agritechnica. Recently, Fendt announced that, unlike the X-Concept tractor, it has continued development of the E100 and believes that the tractor is in the final stages of development and will soon be ready for commercial release. But what about the principle behind the X-Concept tractor, with electric drives replacing hydraulic systems? Has that idea died, or is it still a concept for the future? I asked Josh about it. Do you think electric drives will replace hydraulic drives at all?
I think the roadmap is out there. The length of that roadmap is probably the thing that's hard to define, because it also has to be cost effective in order to do that. So with the kinds of power requirements that we have in those areas of the machines to do that work, we know that, right, anything is possible within reason, but it also has to be cost effective enough and interesting enough for our farmers to take the true benefit from that. In smaller areas requiring less horsepower, I think that you can look at that. I mean, if you think about that, maybe on the smallest end of the scale, even just with electric actuators and the feedback and the simplicity of what an electric actuator is versus a hydraulic cylinder, where I think we've taken some responsible changes there within the architecture of the machine to control it in that way, where we can maybe reduce some of the weight, simplify the machine a little bit one way or the other with some of those electric actuators as it's cost effective and makes sense. It's probably the beginning of getting into some of those controls.
But we're looking at a pretty long timeline likely before we see major changes.
Based on the cost of those items right now, yeah, it's a lengthy timeline. I would say it's definitely something that we are investigating. That's kind of where I get to anything is possible. I think we know we can get there, but we also have to build an affordable machine. Affordable is kind of a tough word these days anyway, with the cost of steel and iron and everything.
Affordable.
Yeah, exactly.
We are on the brink of a transformation as an industry, and it's a really good time to be in the industry. You're going to have advancements in diesel combustion engines, of course. We are looking at CNG, LNG, natural gas technology, which are definitely cleaner than diesel from an emissions perspective, and electrification and fuel cells. So electrification as a company, as you know, we have both the commercial vehicle side and ag and consumer side of it. We have been doing electrification for a number of years. We've had electric buses, we've had hybrid buses, electric delivery vans. So electrification as a topic is not new to CNH, right? And I think we're doing a lot of technology transfer from the commercial vehicle side into ag and construction side of it. So so it's one of the main technology themes that I'm driving in the company, and it applies to both agriculture and construction. Just like in automotive, right? You have to take a look at the customer duty cycle and see a variety of things going to play as you do a technology selection, whether it's a full electric vehicle or whether it's a hybrid vehicle. It all depends on the customer usage, customer duty cycle, your charging infrastructure where that's available, and ultimately the capability of mainly in this case the batteries. What the energy density of the batteries are, because they become the longest pole in the tent as you start to look at electrification. So you kind of balance all of that, and we've had development vehicles running around with hybrid electric technology. You mentioned the TLB that we launched it as a concept vehicle in last year's ConExpo. Last year, a year before ConExpo. No, it was 2020 ConExpo. And even 2019, we had a hybrid vehicle in Agritechnica with one of our Steyr concept hybrid vehicles too. So the way we bring to the market, Scott, is we start off with a sort of a concept vehicle, which is a fully drivable vehicle, by the way. It may not meet the cost targets, but it's a fully drivable vehicle. And we do get the customer feedback. We use that opportunity to do a lot of customer feedback, customer clinics that happen at the shows, and we use that to evolve how we do our products side. So we match the technology to the customer needs, and clearly you're going to see more and more electrification products coming out of CNH. And I would say electrification is a spectrum. It's not just on the propulsion side of it. You can electrify the implements. You can electrify, hydraulic systems. So you have electro-hydraulic systems, very, very similar to what happened in the automotive space, where things get electrified at a subsystem level. And then the propulsion system became a hybrid combination of gasoline and in this case hybrid, and in this case diesel and electrification, and electrifying the drive lines, electrifying the axles, and then going into we would call a full EV with no hydraulics in it. So it all depends on the application. On the tractor side, we see that there's three spectrums of electrification. In very, very heavy equipment, large tractors, it's not economical to have the size of the battery that can actually get the range that the customers need for that. So there we see more of a hybrid solution. But on smaller tractors and smaller construction vehicles, we see a full EV opportunity. Hopefully that gives you a context of how we're thinking about it.
So you mentioned in high horsepower tractors, for example, you'd be looking at a hybrid solution. What sort of hybrid would you envision? Would that be like, for example, AGCO had the X concept tractor, that a diesel power engine that ran a generator. Would that be what you're talking about, or do you have other concepts?
We have other concepts, by the way. We have our own proprietary concept. You have the concept of serial hybrid, parallel hybrids. There's the various concepts there depending on the value proposition and what problem you are trying to solve. But no, we will be looking at as you know, we do design our own drive lines.
Right.
So So we have all the know-how in-house to, again, the interesting thing is that getting the right customer performance and the value proposition they're looking for, right? Hybrids offer a benefit of, quietness and a lot more, launch performance because you can have the boosting available with electric motors. So there's, and then obviously at the end of the day, you can actually use electric implements, electrifying implements. And there we do our own implements, and we also partner with other companies who are implement manufacturers. It's quite exciting though. This whole space is changing significantly with increasing emission standards that are coming in for conventional diesel engines. And both in particulates and globally, it's not just in the US or Canada, globally. And then the after treatment system becomes quite complex to manage the emissions. So electrification is becoming more. It's all about efficiency, Scott. Anything you can do to reduce the waste of your system, to me, that is, and electrification is one of the pieces of the puzzle there to help solve it. We have, hopefully that, and then clearly, I don't want to miss the fact that, combustion engine today, we continue to do advancements in combustion engine. How do we make it more efficient? How do we take the, emission fuel consumption out? So those are the things that are ongoing as a part of our portfolio. And clearly, as I mentioned, natural gas becomes a good alternative, which is, which can provide the range. It's not a big disruption to the engine because some things change in the engine. It's a very, very clean source of fuel.
Do you see a future where diesel no longer plays a part in off-road equipment?
If you ask me, I think diesel will always be over time. If you just look at the next 10-year horizon, right? I do see the diesel, still absolutely being there. And then, as I mentioned, in diesel, we are constantly, innovating, finding better technologies there. Who knows what happens after 10 more years? It all depends on what happens to, if the regulations come in and say, drive it to a very, very, very low, just like what's going on in automotive now, right? Every company is kind of backing away from conventional combustion vehicles that you could kind of see 2030. People, they are going to go full electric. I'm seeing that from every major auto manufacturer. But having said that, they'll probably, have to maintain the conventional combustion engine. So it's in the next 10 years, I would say absolutely we will have combustion engines. It's hard to predict what happens after 10 years.
Are you seeing a lot of demand for alternative drive lines, alternative fuel sources? Is that really a strong pull for corporations like CNH?
Yes, it is a strong pull. We are seeing that as an example. If you go into vineyards, there is a strong interest from those customers who are very, very. It's a very niche application there, right? They need some specific things. So they that's an example of they're actually asking for this. Our the project Zeus, the one you mentioned, the TLB, electric TLB, we are actually testing it at a customer site in New York. One of the electric utilities in New York is actually having those vehicles and they're testing it. So we're seeing demand come from various places, but to have a massive technology propagation will take another 4 or 5 years, I would think, on it become more of a standard. But we are seeing the movement there in terms of the green movement that we're seeing from all our customers.
Like we're pretty much almost universally diesel for just about everything. Do you see that the dependence on diesel morphing into a combination of energy sources?
And you're spot on. Absolutely. Absolutely. I see that happening in the next 4 or 5 years. You see more and more of that. The smaller applications which do not have anything more than an 8 hour range that they need, 8 hour autonomous range that they need. I see them going full electric. It simplifies the system. it really, really simplifies the system when you go there, because you don't need this combustion engine and the after treatment that goes along with it. For customers that you don't have the infrastructure, or the battery size gets to be so large that it's impractical from a cost perspective, I see a combination of, a hybrid solution potentially, but and even CNG LNG, because it is, it's 98% cleaner from an emissions perspective. If you think about it, particulates, etc., compared to diesel. And then, very, very, very large tractors and combines, etc. I see maybe an electric boost, but the combustion engine will still be the main source of power, till the value proposition of electric motors, power electronics, and batteries kind of get to be more friendly from that sense. So yeah, the next 5 years you're going to see more and more of that.
One of the ways major brands develop new technologies is by partnering with or taking over smaller startup firms that have already made significant gains and are ready or nearly ready for commercial release. New Holland has done that with a small California company called Monarch that has designed a utility class electric tractor. I spoke with New Holland's Mark Lowry about how the brand is approaching alternative drivelines.
We just announced a few weeks ago our involvement with Monarch in order to participate with their electric tractor platform. Again, smaller tractors, so talking under 60 horsepower here in this case, but one of the first tractors that's fully integrated with electric propulsion and autonomy. So we'll continue to work with them. Still very much in the beginning stages, though, in terms of our work with Monarch.
But several years ago, New Holland was showing its NH2 tractor, which used hydrogen to create electricity to drive the tractor through a unique electric driveline. But the brand has since shelved that project in favor of another alternative fuel tractor that runs on methane or CNG.
So what's I understand that project has ended. So what was the reason for that?
Well, I think generally we've continued to shift to other projects that we can reliably deliver both the fuel source and the engine solution that can be, I would say, commercially viable for farmers globally. So as we've continued to shift around to figure out what's right, I think you've seen New Holland look at several alternatives. Of course, hydrogen at the time being one of them, not quite what we would say economical from a fuel delivery standpoint today. And shifting to other items like particularly like methane as it ties into our energy independent farm concept and other items. So I don't think many things are off the table, but we're continually shifting to what's viable and what we can bring to market, what I would say more quickly to allow benefit for farmers, producers, folks inside and outside of agriculture.
So now, aside from the partnership with Monarch, New Holland's attention has turned to an alternative fuel, more conventional tractor that uses a standard driveline and runs on either methane or CNG.
This methane CNG concept uses the traditional driveline with just engine modifications to accommodate the new fuel. Am I correct in that?
Yeah, correct. So it allows us to utilize an existing platform, and again, kind of goes back to my comment of being commercially viable a little sooner in terms of being able to put that engine platform onto the existing driveline and truly have specifically with the methane power plant a very similar torque and horsepower generation capabilities that's comparable to the horsepower of what's generated or expected from diesel today. So that's part of understanding that we'll need to encourage adoption, particularly of another fuel source that folks expect that it's going to be able to do the same work and quality of work out of that tractor platform. And so that's really the goal in what the methane tractor delivers for us.
So where's the project at right now with respect to the methane tractor? Are we going to see commercialization soon, or where does it stand?
Yeah, I mean, we're very much in the launch timeline. So we're going to have a unit here in North America later this year, where we're going to commence real test activities. So an actual unit, pre-production unit, and then we'll start full production of those in late 2022. So we're about just a little over 12 months away of being able for folks to write an order for a methane tractor at this point. It'll come a little sooner in Europe, but that's what we're looking at for North America today.
Which tractor lines are going to get the modification?
So it would be comparable with our T6 series tractor, which is maximum 125 PTO horsepower, around 180 engine horsepower today. So the T6 series is the lineup that will receive the methane technology.
Do you envision that going higher up the horsepower ladder to the other models, the 7 and the 8?
Very good question. When I said earlier that nothing's off the table, I mean, we continue to look at several scenarios, including electrification up and down the horsepower line. So certainly envision that there will be continued developments on methane tractor. No firm timelines on that at this point. But again, the goal is to make sure that whatever power plant we deliver can deliver the same power requirements that agricultural producers have today. So however we get there, could be a number of different technologies and items, but it's been important for us to focus on the T6 series first with the methane tractor, prove that it works as expected, prove that it's a good replacement for traditional diesel power, and then we'll determine where we need to go next.
Well, that's a look at what you can expect to find under the hoods of vehicles and machines in the coming years. Battery electric vehicles are set to take the market by storm, but the internal combustion engine isn't done just yet. Companies like Volvo Trucks and, as you saw, New Holland think there's a future for it. But instead of finding diesel fuel in the tank, you may find hydrogen. Well, in the time it took you to watch this presentation, the sun's come out, and the day's warmed up. Engineers have continued their work on coming up with ever more technologies to use. My dog's been hankering for a walk. And I added one more battery electric vehicle to my fleet too. Well, I hope you enjoyed this segment. Thanks for watching.